All right, so I've started recording the video, the class. So whoever doesn't want to be on the in the video on the YouTube channel, make sure that you're not turning on your video like me today. And let me share my screen. Um, Please let me know once you're able to see my screen. Everybody can see it. Everybody can see my screen, right?
Yes, sir.
Okay. All right.
Yeah.
So quickly, what all did we learn yesterday? We learned about uh, the. I'm trying to recall. So we learned a standard deviation, variance, range. What is the meaning of standard deviation? How we can relate that with any real life scenario? How do we interpret based on data? How do we use elimination techniques for getting the right answer? The other things that we learned yesterday. Any question, doubt about the things that we covered yesterday? No, you guys are shy. Okay, okay. And again, okay. If there is no doubt, wonderful. If there is doubt, that is also equally better. So don't worry about asking questions. Okay. So fine. So now, then we were talking about the y-intercept form and the slope of a line or a linear equation. You guys remember? Recall. Now let's spend 5 to 10 minutes to understand what is meant by the slope. Okay. And how do we relate that with the slope intercept form in a linear equation? And then while I'm teaching that, if you guys have any topic in your mind that you would want me to cover additionally for you, let me know, or else I'll just go with my flow. Okay, fine with you guys, everybody?
Yeah.
Okay,
Sir.
so now let's look at the slope of the a line, and let's try understanding the slope, and then we'll try relating that with a linear equation. This is one line, this is one more line, this is another line, or let me do that in a sequence. This is one line, this is another line, this is another line, this is another line, this is another line. What is that you see between these? I mean, I keep on saying line, but this is nothing but line segment, right? Now you tell me, by looking at these five line segments that you see on the screen, what is your interpretation as a child? Don't try becoming a mathematician, okay? As a normal human being, what is that you see, and what would be your interpretation? And it can be as practical an answer. There's no wrong answer, okay? So just be brave and share that with me. No guesses. See, this is one thing that that is different about us human beings versus the other living things on the earth, right? We observe. So likewise, I'm just trying to get your observation of these line segments that you see on the screen. Okay. One observation is, again, don't laugh at me. Okay. This looks like this line segment is lying on the floor or sleeping on the floor. Yeah. Seems to be waking up. Yeah. Has half woken up. Has woken up little more, and has now stood up. Yeah. If you look at these line segments as a child, this is like waking up, the process of standing from lying on the floor. Yeah, that is one observation. Agree with me?
Yes,
yeah,
sir.
Okay. Second observation would be that okay, these line segments are horizontal and gradually it is becoming vertical. Yeah, horizontal to vertical. This is second process. Again, now you're getting little mathematical. Third practical example or response would be that okay, here it is flat. Here I see some slope. The slope is increasing. The slope is increasing. The slope is increasing. Yeah, make sense?
Yes, sir.
Okay. Now, the third example that I was giving to relate it, when I say slope is increasing, that is where we see slope is increasing. It is becoming a little more steep. Here it was shallow, little steep, more steep, more steep, more steep. So if somebody has to walk along this one, it's much easier. If you have to walk along this one, it's less easier, even less easier, more difficult, very difficult. Yeah. So so basically a slope says if the slope is more, it takes more effort to walk along that. Or at one point in time it becomes difficult. If you're driving a car on this kind of a road, flat road, it's much easier. If it's slope, engine needs more power. It needs even more power. Here you probably need a four-wheel drive. Even if you have eight-wheel drive, you cannot drive here. Yeah. So simple example is slope is something that is determined by how steep it is. Okay. You guys agree?
Yes, sir.
Okay. Now all that we were talking about so far was more to do with the practicality of it. Let's look at it mathematically. This slope versus this slope. Which one has more slope? Higher value of the slope. This is, let's say this is 1, this is 2. Which one has a higher slope? 1 or 2?
Second one, sir.
And one has higher slope.
two,
Now, if you look at this again, so far we are talking about the practical thing only. We have not related that mathematically. We are saying this is a lower slope, this is a higher slope. Now, how do you know a slope is higher? How you can relate that mathematically? Now look at this in the xy coordinate. Okay, this is something with a lower slope. This is something with a higher slope. Okay, let me clear it. So let's look at in a coordinate plane. This is a lower slope. This is a higher slope. Yeah. Why you call this as a higher slope and why this is a lower slope value? Any guess?
Because the line in the second one is much more steeper with a higher rate of change.
That is the right answer, but I want to even further break it down. So this is my y-axis, this is my x-axis, this is my x-axis, this is my y-axis. See, another thing you will see. Let's say here it is. Let's say 1. This is 2. This is 3. This is 4. 1. This is 2. This is 3. Here, if you see, let's say this is 1. This is 1.5. This is 2. 2.5. Here it is 1. It is 2. Here the value of y is changing faster, right? In the second case, here if you will see, the value of y is changing faster. Here it is much shallow, right? So it takes a longer distance. It has to cover longer distance in the x direction to for a corresponding increase of y. So from 1 to 2, it had to kind of cover from here to here. But in this case, from 1 to 2, it just had to cover small distance. Or other way to represent that it will be if my slope is higher, that means value of y is changing much faster. Or for small increase of x, you will see the corresponding change in y is more. Yeah, because y is the this side of the thing, right? For a very small change in x, the value of y is changing faster. Here, if you see from 1 to 2 when it went in the x direction, it changed from 1 to 1.5. Here, when it went from 2 to 3, for one unit change, it changed by zero point 0.5. Here, same thing, one unit change another unit in the y direction. That means the value of y is changing much faster for every unit change of x. Are you guys able to relate what I'm saying? Yeah. So
Yeah.
when you say slope of a line is high or a line is steep, what it means is for every change of x, the corresponding change in y is more. Okay. So since you guys are much older than the toddlers or the elementary school kids, so you will represent that in a different way. So I was teaching you guys like how would a toddler look at it? How would a normal person look at it? Since you guys are all in high school, so here your approach would be slightly different. You will be a little more mathematical with your response. If you say this is a you know uh, s- has a lower slope versus this have has a higher slope, your response would be yes. This has a lower slope and this has a higher slope because in the case of the second scenario, for every change of x, the y changes much faster. That's if the y changes much faster, see, it will keep on becoming like this. Okay, it will keep on becoming like this. So, in simple terms, when the slope is more, that means the value of y is changing much faster for every change in x. Does that make sense?
Yes, sir.
Okay. Everybody with me?
Yeah.
Yeah. Slightest of doubt, slightest of ambiguity. Hey, Shivat.
I said I couldn't join yesterday because I was house shifting.
I know. Daddy told me about that. So it's okay. We had the video of the class for yesterday, and we have not covered much. So you can watch the video of yesterday's class and let me know if there's some doubt. Okay. So yesterday we covered standard deviation, range, and and variance, which we have covered in the past also. But just look at it one more time, and then let me know if you have any confusion. And then right now we are trying to understand the linear equation and the slope, and we are trying to relate that how that works. Okay. So
Yeah.
except Srivatsab, anybody has any doubt with respect to whatever we have covered so far? No. See, you guys have to start competing with your teacher. Okay. You have to always keep on trying to find opportunities to prove me wrong. Okay. If you do that, that is when you will become better than me. I'm not saying that you have to just do it for the sake of doing it, but I'm saying always challenge me with example, with questions, with doubts. Okay. That's the only way you will learn faster than I'm wanting you to learn. Okay. All right. So that was the lighter side of it. Now, so what I was saying was that if you are just some I'm just summarizing before I move on. So between these two lines, when we say this has a higher slope or this is more steep than this guy, here my value of y is changing much faster for every change in x. Okay, look at this. Here, if x changes by 1 from here to here, y changes only this much, very small number. Here x changes by 1 here to here. See, your y has changed this much. Yeah. So whenever you're talking about a steep line segment or a line versus a shallow line or with a line with a smaller slope value, you clearly know that your value of y is changing faster. That is why it is higher value in slope or it is steep. Okay, now let's look at it mathematically. So remember what I said? This line The value of y is changing slow for every change in x. This line, the value of y is changing. Let's say these are 2 points. These are the 2 points. Okay. Here, there's some value for y. Let's say this point is x1, y1, and this is x2, y2. This is, let's say, x3, y3, x4, y4. What did I say? Slope. When I say slope is more, that means the value of y is changing faster for every change in x. So here, what is the change of y for every change of x? So here, if you see in the second case, value of y changed from y3 to y4. So y4 minus y3. This is a change in y. And what is the change in x? X changed from x3 to x4. So this is my change. For this much of change in y, this much of x has changed. So if I divide this by this says for every change of x, what is the corresponding change of y? And this is what is nothing but your slope. Okay. For every change of x, how much y has changed, or how much y has changed for this much of change in x, that is what is your slope. And that is how, if you are given a situation where somebody says that this is a line segment or line where which is represented by y equals to 2x plus 3, and this is similar to my slope intercept form equation. This is my slope and this is my intercept on the y-axis, meaning where will this line segment or line touch the y-axis. Okay, so here 2 is the slope. 2 is equal to m is nothing but the slope. Okay, so this is the intercept, this is the slope. You can relate it this way. Or else if somebody gives you that, okay, you can draw a line with 2 4. This is first point. Second point is, let's say, minus 3 2. You can draw a line between these two, find out the slope of this line. Very easy. Slope of the line is, this is, consider this is the first point, this is the second point. Let's see what is the change in value of y. Y changed from 4 to 2. Okay, 4 minus 2. This is the change in y. What is the change in x? It changed from, oh sorry, my bad. 2 and 4 is first point, and let's say second point is 3 and minus 2. So I'm saying this was my point number 1, this is my point number 2. The slope of a line is, what is the change in value of y? So change from this to this, meaning you will subtract this number from this number. So I'll subtract I'll subtract this from this one. So this was my final point, this was my starting point. So this minus this, divided by what was the corresponding change in x? X changed from 2 to 3. So this is my final point minus this point. This. So my slope is minus 2 minus 4 becomes minus 6, divided by 3 minus 2 is 1. That is, my slope is minus 6. Okay. So from, if you are given just 2 points and if you have to find out the slope, this is how you will find. People might say, okay, find out the equation for the find out the linear equation which goes through the point 2 4 5 1. If you have to find that out, first thing you will do is find out m or the slope. So y change from 4 to 1. So 1 minus 4 divided by this to this. So 5 minus 2. It becomes minus 3 by 5 minus 2, 3. So slope is minus 1. Okay. Now, you know the equation is y equals to mx. I can represent this in form of y equal to mx plus c. Now, what did we find the value for m? Minus 1. So I will say, okay, y equals to m is minus 1 into c. Okay, so here it becomes y equal to c minus x. This is minus x. Y equal to c minus x. Now, since this goes through these 2 points, you substitute one of the value to find out the value of c. Let's say 2 and 4. If this is 1 point on this line, y equal to c minus x. So y is what here? Y is 4 equal to c minus x. What is the value of x? 2. So 4 equal to c minus 2. So c will be equal to 4 plus 2. C equal to 6. So you found the value of c by substituting this after you found the value of m in this equation. Simple thing. Okay, let's say I have a point like this. If I have second point saying, okay, these are the 2 points through which a line goes, find out the equation for that line and the slope. So we know that, okay, y equals to mx plus c. This is what we know as a slope intercept form. I can use this form. Here, first thing is we'll find out the slope, value of slope, and then by using these two, and then again, since we'll pick up any of the point and substitute that value in the equation and find out the value of c. And that, let's say in the previous case, we found m equal to -1 and c equal to 6. So my equation becomes y equal to mx plus c. M is -1, mx plus c. C is 6. So this becomes my equation for that line. Y equal to minus x plus 6. Or you can say y equal to 6 minus x, whatever it is. So far we have just tried to understand what does slope mean and how do we relate that practically. And then how do we use, let's say if we are given a situation where I have only 2 points known, if I have to find out the equation, how do I find out the linear equation? Or how do I find out the slope? The other thing that will be asked to you. Now, before I move forward, any questions so far?
No, sir.
No?
No, sir.
No.
Okay. Anybody, I heard no from two of you. Anybody having any doubt creates excitement for me.
No, sir.
No questions? Okay. A third?
No,
No.
sir.
No, sir.
Okay. Dhanushri?
No.
No. Okay. Rutvik?
No, sir.
Okay. Okay. Now let's look at some. Uh, do you guys have anything that you want to uh, you would want me to uh, touch upon, or I can continue with what I'm doing? Anyways, today's class is a little shorter version of the class, so probably I'll let you guys allow me to continue. Okay. All right. So let's look at some interesting aspects. Okay, and you might find this really fun. Okay. Now let's look at this line segment, and this line segment. Okay. What is that you see here interesting about them? What you can relate? I mean, again, based on whatever we have learned so far, this line and this line. What is your observation by looking at these two?
It looks like one of them is negative and one of them is positive.
Yeah, that's a point blank answer. I will take that. But any other observation?
For the second line, when
Mhm.
the x value increases, the y value decreases. For the first line, if you increase the x value, the y value increases too.
That is another good answer. Yep, very nice. So these are the two answers I will take. Okay, there's no third answer right now here. So these are the two good answers that I got from you guys, and that gives me the confidence that yes, you understand it well. So here, as you said, right, this One is positive, one is negative, meaning uh, this slope is positive. When you say a slope is positive, meaning every increase of x, there's an increase in value of y. Or if the value of x decreases, y value of y also decreases. So they are kind of uh, aligned with each other. So if one increases, other increases. If one decreases, other decreases. I mean, value of one coordinate increases, value of other coordinate also increases, and they are aligned. That's why it is called positive. So meaning for every positive increase in one coordinate, there's a corresponding positive increase in y coordinate. That's why it is called positive. Second one is negative, because here you see, if you are going in this direction, what you are doing actually, you are decreasing the value of x, and that is when you see y increasing. If you increase the value of x, what do you see? Y is decreasing. So by increase in value of one coordinate, the other coordinate decreases. That means it's having adverse effect. It's like eating medicine to increase your fever. Yeah, that's why it is negative. Yeah, you're eating more medicine and your fever is, see, you're eating more here it is, let's say -4, -3, -2. You're eating medicine by reducing from -4 to -3, -2, -1, and then 1, 2, 3, 4. You're increasing your medicine intake and your fever is increasing actually. Sorry, fever is decreasing. You're increasing your medicine intake, your fever is, I think I'm giving a bad example. So, okay, here in this case, you are eating more medicine, your fever is increasing. More medicine, your fever increasing. Here, you're eating more medicine, your fever is decreasing. Okay. So this is negative. This brings negative effect on increase of one parameter or one coordinate, brings negative impact on the second coordinate, is why it is called negative. Okay. This is one example. Second example, you said, I mean, both are relatable again. Second answer that I got from you guys was that by increase in one of the parameter, one of the coordinate, the corresponding value increases for the other coordinate. And here, in this case, this is opposite. So that is exactly what it is. Now, a quick fire thing. If you come across a question, okay, let me give an example, okay? Uh, for some of you who are going to appear for SAT exam sooner, you will say, okay, this is a line, and they'll say, okay, this is my coordinate 2, 3, 4, 8, and find out the slope for this guy. Which one is the right slope for this one? Okay, slope m, and then you are given four answers. One answer is 2.6. Second answer is 0.15. Third answer is -2. Fourth answer is 0. Okay. So here, to your point, Isha, right? Yesterday, as you were saying, we know that slope is equal to y2 minus y1 by x2 minus x1, meaning whatever is the change in y for every change in x, that is what my formula is. But would I want to calculate and then get it, or I would want to use elimination technique? I will do both. First thing is I would want to eliminate. See, here what do you see by looking at this line segment itself? That okay, whenever my x is increasing, my y is also increasing. So this is a positive slope. Okay, like some of our teammates were saying. So it's a positive slope. So anything which is negative, I will knock it off just by looking at this. I'm not doing any calculation yet. Okay. Now, second thing is, what do you mean by a zero slope? Meaning y2 minus y1 is zero. Meaning value of y is remaining same. Then only it will be zero, right? Any slope will be zero when then these two are same. Meaning this is on the same line. That is when your y value will be same. Okay. M will be zero only when your numerator is zero, correct? And numerator will be zero only when it's a horizontal line. Then only your y coordinate value for this point and this point will be same. So this is not a horizontal line. You clearly see that this is different. Knock it off. Yeah. Two options you have ruled out without even trying to solve this sum. Then comes this one. If you say 2.6 versus 0.15, I might not have given the right options here, but I'm saying between these two also, if you have to see, just look at these numbers 7, 8. It's changing from 7 to 8, and this is x is changing from 2 to 4, meaning x is x is changing faster. X changed from 2 to 4, y changed from 7 to 8. X is changing faster, meaning y this is changing slow. So 8 minus 7 is 1, by 4 minus 2 is 2. This has to be less than 1. This option is also gone. And obviously this is not the right answer. What I'm saying is when in the actual exam you will have the right answers. So essentially for this kind of a sum, which might look cryptic, but you can use elimination technique for solving these problems much faster. Just by having the right observation, just by reading the question correctly, and then wrapping your head around that and putting a structure to how you want to approach this. Am I making sense here? These kind of
Yes.
these kind of problems you'll be able to solve in 30 to 40 seconds or maximum a minute, which is still a much better job, provided you approach it right. So simple example is whenever you see a line segment like this versus a line segment like this, your first interpretation, oh, this is positive, this is negative. If I am given a question which has this kind of a thing, meaning value of y is decreasing with increase in x, it has to be a negative value. Just by looking at the options, you should be able to rule out. If your question says four answers for slope as 1.2, 0.5, 0.6, and minus 1.2, you will, without even reading much, just by looking at this diagram, you'll say, okay, this is by no means a positive slope. All the positive options are knocked off. Done. 10 seconds deal. Yeah. So that is why when I keep on stressing on the fact that don't jump onto solving a problem, this is the reason. Because when you look at the problem, think about it, and while it might look like a cumbersome exercise, when I keep bragging about this, right? Read, analyze, and then Nike or do it. When you will think that, oh, my teacher is asking me to do additional things by reading, analyzing, and then doing it. Doing it is something that I cannot avoid. I still have to do it. So if I'm adding two more steps to it, am I not going to take more time? Answer is no. Because if you just do it, you might do that in iteration. You might learn it the hard way after doing 2, 3 attempts. If you do this reading and analysis beforehand, this part becomes very optimized, or it takes least possible time. At times, you might not end up even doing this Nike. By reading and analysis itself, a lot of short answer questions you'll be able to do by without even doing the problem, because your analysis will give you a lot of clue with respect to what is the right answer or approach to look at. Yeah. See, I'm selling my idea. Do you guys agree to what I said?
Yeah.
Make sense? Oh, yeah. Yes. Anybody having any question?
No, sir.
Okay. So today, as I said, this is going to be a very short class. So let me give you guys two sums, okay, on the board. I would want you guys to solve that in next 13 minutes, next 10 minutes actually. So that the last 3 minutes we'll keep for question answer, and we'll wind up by 12:50 today because, as I said, I have some dependency for my travel. Okay. So first question is -3, 1. This is my one coordinate. Second point is 4 and 2. Find out the linear equation and slope for this one. Okay, this is one question number 1. And second one is, I have a line segment My question is, what is the slope for this one? I have not given you any option. Okay. I have not given you any information. This is just I'm showing you this in the coordinate plane. I'm saying what is a possible slope value. Okay. So I will say zero point 0.5, 1.2, minus 2.6, and minus 1.1. I'm just giving you this kind of a random question, okay? And this is going to be much based on your analysis. So solve these two in next 5 to 7 minutes. That's what you have, and it's doable. So for the first one, give me the linear equation. Give me the linear equation. You don't have to tell me the slope because, anyways, if you have to write the linear equation, you'll end up finding the slope. And for the second one, tell me which one is the answer. A, B, A, B, C, and D. Okay. And I'll take first three answers only so that I can explain to rest of you. Would not want to wait till end. Okay. So let's get started. You all understood the question, right? First one, I have 2 points and I have to find out the linear equation. Second one, I have a slope given, no information. I just have to make the right estimate and see which one is my right value for the slope. We are trying to find out the value of slope. Yep. Who is ready? Yes, Praneeth. You ready?
Yeah.
How much is your answer for the first one? What
For
is
the
your
first
mhm.
for the first one, I got y equals 1/7 x plus 10, sorry,
1/7 of x plus
plus 10 7, 10/7.
10/7? Okay.
Mhm. And for the second one, I believe it'd be like d.
D.
Mm-hmm.
Okay. Okay. I'll take that answer. Let's wait for at least one more, if not two. So I'm waiting for Atharv, Vaibhav, Dhanushree, Shah, Rutvik, see what's up. Whoever comes first. Are you guys anywhere close? Rutvik, Sivatsav, Isha, Tharv, Nanushree. Oh, no, everybody's quiet. Okay. So just because we have time constant today, so I'm just trying to go a little fast here. Can everybody hear me clear? Everybody with me? Request everybody to pay attention here. See, there's nothing difficult about this question, and I would repeat myself, or kind of say the same thing that I've told before. So same in this case, right? I did not give any information here, so it was left to your guess. Second one. So if you look at this, what is the observation? With increase in x, y is decreasing. Okay. So any that means this is a negative slope. Negative slope meaning all the positive options are knocked off. Now here, other thing that you would see is this slope is pretty what you call uniform. If you look at this versus a slope like this, what you see is here in this case, there's a very rapid change in y for every change in x. This is a very slow change in y for for every change of x. Right? This is more like a flat. This is very rapid. This one is very much somewhere in between, meaning it looks like when you if you have a graph given, right, you will see that every unit of change in x is bringing kind of 1 unit of change in y. So that's why it's certainly not double or close to triple, right? Otherwise, this would have been much more steep. Okay. So that's why this is not an option. This will be the option, as Pranit was saying. Because here it looks pretty uniform. If you see a graph which is like this, you can clearly see that, okay, this is falling somewhere in between. Okay. Meaning X and Y is changing pretty uniformly. If you see this, that means Y is changing very slowly. For every change of X, Y is changing very little. So that means Y, if Y is little, the value will be little, very little, much less than 1, much less than, much closer to 0. If it is like this, vertical line, meaning Y is changing very fast for small change in X, that is when this value will be much bigger negative value. When I say much bigger negative value, meaning minus 6.2 or minus 6.9, whatever it is. So by looking at this one, you can simply guess that, okay, fine. X and Y are changing almost at the same pace. So this one looks to be the option because this one would have been a different scenario. Now, in this case, it's simple. You will first find out the slope, which will be y2 minus y1. This is y1, this is y2. This is the first point. So it is y1 x1, this is y2 x2. You'll do minus y2 minus y1. 2 minus 1 is 1 by x2 minus x1. x2 is 4 minus x1. 4 minus minus 3 will be 4 plus 3. So 1 by 7. M becomes 1 by 7. So that's what I see here. Now you will substitute one of the value, this one, in place of y and x, in y equal to mx plus c, to find out the value of c. Here you got m equals to 1 by 7, and x and y value you will pick from one of the points. You can choose always which point you want to choose. And then substitute that, you'll get the c, value of c. And then once you get m equal to 1 by 7 and you get the value of c equal to something by choosing one of value, I'll just assume what Pranit has done is correct. So 10 by 7. 10 by 7, let's say if c, my value of c is this, then y equal to mx plus c. So 1 by 7 into x, mx plus c is 10 by 7. This becomes your equation. If you want to simplify it further, You can also do that. Do the LCM, and 7 is common, so it becomes 7y equals to x plus 10. That becomes your equation. Okay. So, in summary, whatever we have done today, these are very straightforward things. We just learned how to interpret or get the meaning of a slope of a line. So we have I have requested other kids to join. So Bivan and everybody, whoever is joining, you guys can just wait while we are finishing up the class for senior kids. Okay. So yeah, Bivan is joining. So yeah. So all the kids for level 2, they will be joining shortly. Here in the meantime, so whatever we have learned so far, a summary of that is we learned to interpret what do we mean by slope, how do we read the slope as positive or negative just by looking at it, and then how do we relate that with our understanding of the slope intercept form, and find out the value of the find out the linear equation actually by finding the slope. How do we find the slope? It's y2 minus y1 by x2 minus x1, meaning how y is changing against every change in x, and then we use that for deriving the slope, and then we substitute the value and find this then we find the linear equation accordingly. So any questions so far? I was just going at my pace. I know we were a little hard pressed for time today, but then I hope I did not waste your time and you guys were able to learn something based on what we did in the class today. Is that a fair statement? Not a fair statement? Okay. So what I'll assume that whatever I said, you guys agree to that. Uh, and I'll upload the video of the class in a bit so that you guys can take a look at it. And if you have any doubt, you can certainly